Welcome to everyone. Today we are going to discussing about another important session on a compute network, which is RAP. So what is meant by this RAP? So RAP is nothing but a routing information protocol. And so in this session we are going to discussing about what is RAP protocol and what is link state routing, and while implementing this link state routing, what is the need of this OSPF1 we discuss in this session. What is RAP? What is routing information protocol? So routing information protocol is a dynamic routing protocol. So previously discussing about the protocols, those are a static protocol. What is static? A manual operation is manual entry is required, that we calling as a static protocol. But in this RAP protocol, that should be acting as a dynamic protocol. So systematically or periodically update the information, that we calling as a dynamic routing protocol. So this routing protocol is uses like how many hop counters there, like what kind of scenario we are using that one, based upon the counting mechanism of how many things are we are using, how many hubs are we are using that one, how many hubs we are using that one, or how many routers we are using that one. So that kind of count we are measuring, and we note it down in the routing protocol value, and we have to maintain all the information in the prescribed values only, we calling as routing metric protocol value. So we have to maintain all the information. From that one we have to choose the best path between the source and destination network, that we calling as a routing information protocol. In the name itself is there, we calling as a routing information. So it has to maintain all the hop count value and all the information, how much amount of distance it takes. So all the information noted down the value, and after this one it has to choose the best path. It has to find the best path. Information is transmitted from source to destination, that we calling as a routing information protocol. So in the routing information protocol, the key role should be hop count. But what is this hop count value? Hop count says while we carry the information, while the information is transmitting or moving from one station to another station, so how many routers are involved in the network architecture, that we calling as a hop count. Hop count nothing but number of routers carried between the source and destination, so that we calling as a hop count. So the maximum RAP hop count should be 15, which is 0 to 15 value, and the maximum count should be 16, that is the network value. If it crosses more than 16 value, it comes to network unreachable value. Network can't able to handle the more than 15 value. But what is features of RAP? But while we update network architecture value, while update the information, while information is because in the routing information we grab that one, that information we are changed when we exchange in the periodically manner, because when the dynamic routing mechanism, the periodical manner we go for update the information. So that is the features of in the network layer, that is the updates of the network in the exchange periodically manner values only. So but what is the updates? What is the routing information updates? So here the routing information is always a broadcast, not a unicast level. That should be a broadcasting kind of communication services we are using that one while the routing information is moving. And what kind of full routing tables are used? So here a full kind of architecture, full kind of routing tables are used to send the updates, to send information from one station to another station. Full kind of architecture we are using that one, full kind of network tables we are using that one to send an updates. So this just always a trust or routing information received from the neighbor routers. So this also we calling as a routing on rumors, because it has to depend upon the previous network layer, previous hub points or source point. So it completely depending upon the next layer values only. It may chance us to give the wrong values, or it may chance us to give the current values, but it has complete trust on the what kind of information we get it from the previous routers value or previous hubs value. So that is the reason we calling as a routing on rumors value. But what kind of message format we are using that one? So in the routing information we having as a prescribed message format we have that one. But what is meant by this message format? In the message format level we having as a, like in the previous class we are discussing about the frame format kind of structure we are using that one. Similarly here also we having as a message format structure we are using that one, which means what kind of routing information we have that one, what kind of structure we are using that one, and what kind of format we are using that one, and how the information is stored that one. So all the things we calling as a frame format structure, we calling as message format structure. Apparently we calling as a packet kind of format structure. So that information we calling as a routing information protocol. So here first we having as what kind of command we have that one, and what type of service we are using, what kind of version we are using that one, and how many reserved information we are using that one, because all information stored in forward services. What is the reserved services we are using, which means what kind of reserved kind of information we are using that one, and what kind of version we are using that one to store the information in the various network layer. That also we need done the routing information message format. So here what kind of command level we are that one, what kind of version level we are using that one, and what kind of reserved mechanism we are using that one. So all these things we are noted down in the routing architecture values, so routing table information values only. So but here the command and version we calling as a family zoner value, which means what type of family is there in the based upon the version section, as well as in the reserve, which means always zeros values only. If anything is goes changes, this value may be a changes from 0 to 1s or 1 to zeros. And next one we are storing the network address. If you go for static, we store the IP address value. If you go for this dynamic, we store the logical address value. That kind of network address we are using that one. So and after this one we are noting down the best distance of values only. What kind of distance we are using that one. So when you see this one, two things are there: request to some value and request to all value. So when request to some value, so we have to follow the same protocols, but we having a network address value. But in the request for other metrics value, other kind of operations value, we don't have this network value. Instead of this network address value, we have to capture all the values. Why we are using this one? Because you have to go for this IP address, we are go for this a logical address structure values only. That is request for some mechanism and request for all the senior mechanism. Next one is what is timer in RAP. So we'll see here we having as a prescribed kind of structure values we are using that one. So at the same time we go for this a reserved kind of mechanism we are using that one, right? So we go for this IP address value, or else we go for this a logical address value. And apart from this one, next one is we taken up all zeros are there. So but however unless that one, based upon this timers we are using to support the operations of all the header format, all kind of frame format structures, or else in the protocol architecture services we have three types of timers are there. So information is transmitted periodic manner, which is every 25-35 seconds, or else expiration times are there. After 180 seconds the time should be expired, we started it fresh again. And we after 120 seconds we called as a garbage collection timer. For example, here the information is transmitted from source to destination. I'm using a number of packets are there, as well as a number of hosts are there. For example, host 1, host 2, 3 and 4. A number of hosts are there. So here information is transmitted through this host mechanism. So how the information is updated in the periodically manner, because RAP is supported system in the form of this dynamic one. So which means periodically update information. So every 25-35 seconds it periodically update the in timer values only. But after 120 seconds any information is not updated, not given information, that we calling as a garbage collection timer. And even though information not received, that should be expired of timer values. And after 180 seconds the things are expired and we shift into the next connection mechanism. But what is the advantage of this RAP? So in the RAP, the routing information protocol, we have n number of advantages are there, because while you estimate small kind of network architectures, for example, we go for this interconnect services. For example, in the commit level, in the small kind of graded commit level, we having some kind of intercom is there. So because limited kind of peoples are present, so the limited kind of routers structures we are using that one. So or else in the home appliances, Wi-Fi services is there. So that is also a limited kind of architecture, limited kind of services we are need to use that one. Single kind of a small kind of architecture we build up that one. So that is a small network which was very little overhead, as easy to handle that one. But at the same time the small networks were easy to implement, because if you using this limited architecture, we have this 0 to 15 range, which is apparently we having as a 16 kinds of hubs are there. So those are a limited kind of router mechanism. So a limited kind of a minimal kind of architecture we are implementing that one. So that should be easily implemented that one. But we having disadvantages are there. What is the disadvantage? So for example, if you are able to develop the architecture, we are able to develop the routing information protocol, a large amount of information we are using that one. So this is not feasible one. A large amount of information we unused a space mechanism value. We are not supporting the large unused space value. And next one is it supports the routers only within the subnet region. So what are the networks comes in the intercom region or internet region, so that we can able to handle that one. Outside the things it should be very difficult. And and these are not a secure services only, because we don't have this any kind of authorization, any kind of authority services there. So that is a main reason for it is a not secure information is transmitted. There is a major advantage and disadvantage of this RAP. And what is meant by this link state routing? In the previous discussing about this routing information protocol, RI protocol. The next one is the link state protocol, link state routing. So in the distance vector routing is there, as well as link state routing is there. Distance vector routing is based upon the purely calculation about this distance value, but this link state routing is the in which each user or each router or each hub is share the knowledge of to the next neighbor in the who are present in the inter-network region. For example, in this inter-network, 10 routers are there. Right, some routers are there. So here each router is share the knowledge to the other router. Each router is share the knowledge to the other routers. Right, whether they may require or not required, or they may be neighborhood require neighborhood hopes or routers. So that is not an issue, but you have to share the information to the next neighbor values only. So apparently it has to share the information to each other user in the who are present in the network values only. We calling as inter-network region values only. But in the inter-network joining, we having as multiple mechanisms are there, which we calling as a learning about the neighbor value. So we need to get the information from the neighbors. We need to ask them. We need to make a note of them. So we need to get the information from the neighbor informations. So that we calling as a learning about neighbors, and measuring the line cost. So how much amount of distance is there? How much amount of credentials were consumed that one? So that we are able to measure the value. They calling as a line cost value. And at the same time, we calling as a build of a link state packet. So while establishing or while building the construction of this link state packet, also we are discussing in this one, because every router has to know the information about how much building is there, how much kind of routers are present in the network, on where to information is transmitted and how to information is transmitted. All the things are we need to building that one. So building of link state packets is important. Other one is distributing the link state packet. So while we are grabbing the information, while we are collecting the information, so we need to share the packets. We need to share the packets from one station to another station. So distribution also very important for us. And at the same time, computing the new routers. So we are able to analyzing the new routes, and while sharing information, while transmitting information, we have to compute the values, which is the shortest path value. That is also analyzing the mechanism that we calling as a link state routing value. So while discussing about this one, the learning about the neighbors. For example, information is transferred from A to B is there. This we calling simple bus network, or we calling as a bus kind of topology services. So here information is transmitted from either D to C to D or D to E and D to E. So this kind of loop kind of structure is there. So we need we need to know the information about each and every routers who are present in the network architecture. So these 9 routers and LAN connection is there. But in this one is a graphical models of this multiple LANs and multiple resources are there. But for example, this one information H having information, also F also having this information, but H is sharing information to H to G or else H to I. Similarly, G to F value or else H to F value. So we need to pick up the shortest path values only from this is the shortest path or this shortest path, or what is the shortest path information is transferred from H to F, that we are able to analyze that one. That we calling as a 9 routers are present in the LAN connection. But we'll see this one. This calling as different kind of topology services are there. But here we have a single topology here. We have this bus topology, we have ring topology, we have a star topology or square topology. We have multiple topology services are there. So these are present to share the information who are present in the respective domain values. It is a graphical model of information values. But what is the measuring line cost? So another important thing we have is a measuring line cost. So here information is transferred from B to C and C to F. So this we having as a broader gateway protocol. So we are able to communicate to this protocol not directly. So that because that comes to a security issues only. So that is the reason. So these are comes to discuss in the parallel serial communication values only. So here information is transmitted, which means a subnet. This subnet wants to share information from east to west part. Are we controlling 2 lines? So we have information transfer from A to B value, C value, and C to F value. Or else information is B to C value or C to F value. So F is the other information transfer from E to I value. That is this is having as a linkage between the values only, that we calling as a information is transmitted, and how many credits are consumed, that we calling as a line cost. And building of this link state. What is the building of link state packets? So here information is transferred from A to B, we having as a 4, and RS A to E we having as a 5 consumption. Which path we choose? We choose A to B path, which is A to B path, consume value is 4. Next one, we choose either B to C value or else B to F value. B to C is 2 and B to F is 6. So we need to maintain all the things. So we need to shift it into the next one. So first we choose A to B value, B to C value, C to D value, which means we have to grab the link state value as well as we follow the state value and we follow the packet level values, which means different kinds of metrics are there, different kinds of zones are there, different kinds of states are there, and different kinds of links are there. We need to follow the subnet mechanism to analyze the link state packet for this subnet. And next one, distribution of link state packet. So while analyzing the information, so we need to go for this a distribution mechanism. So what is meant by this distribution of link state? So distribute in the sense we need to share the information to n number of routers or presence in the network. So here this will use a floating mechanism to distribute the link state packets. At a time we are go for this check the information. So we need to grab, we need to look into the every time we need to look in the flood, and we need to check each and every packet has to be transmit the sequence number or else in the increment number in the new packet. In the receiving section is 0 packet is received, 1 packet received or 2 packets are received. We check the each and every time we need to check the floods value and what kind of information is transmitted and what kind of sequence number is there. We need to check that values as well. So these kind of routers we need to track the information of same source router values as well as sequence value, because here with the link state vector value, link state packet value, which means it has to come to the picture. So if it is checked against the list of packet which already sent, which already seen the information values, and if it is new kind of communication, so what kind of forward lines on there except the packet is arrived. If it is a duplicate, we have to discard it. For example, if we transmit the multiple packets or the information is transferred from source to destination, multiple packets information is transmitted. So we need to grab the information. If already the packets are received, we just discard. How we discard it? We need to understand, we need to analyze whether there is a duplicate packet, then only we can able to discard it. So next one is OSPF. We calling it the shortest path, which is what is the shortest path values only. So we have to open the values. We have to, in the name itself is then open a shortest path first values only. So it is distributed based upon the map concept, which means all the nodes we have to copy of the network, and based upon network we have to each and every network is updated in the regularly manner, in the protocol structure we are updated. So here we are able to distribute the information based upon the map architecture values only. It also supports a multiple circuit load balance. If you go for this, n number of multiples are there, n number of packets are received, n number of hubs are there, n number of routers are present over there. We need to support the multiple routers and multiple circuit load balancing. It coverage quickly, and it support the multiple metrics, and also separate and also coverage the multiple mechanism, multiple metrics in the sense n number of channels are there, n number of hubs are there. So it also support the multiple peoples or multiple hubs present in the network architecture, but it not susceptible for routing loops. It is difficult to analyzing difficult to susceptible the routing loop values only, but it supports the variable length values only. That is a major advantage of this OSPF mechanism. So while you see this OSPF, in the OSPF network architecture, so we having as a, this is the network one and this is another network one. So here we are able to pass information, internal routers are there, or else backbone routers are there, or this go for another kind of network architectures are there. So we have to share the information. First we have to analyzing the shortest path and how many routers are there. We have to make a copy of all these things, and this information is passed to this value, and this is passed to next backbone mechanism, and this information passed to the next one. Here multiple routers are, multiple hubs are involved to share the information till in the next layer value. That should be the outer kind of architecture value. So this is comes to intra one, this is comes to the inter one to multiple one network to another network. So what is the header format? So in the header format, previously we having as a RAP header format, we have maintained the network layer value, network ID value, version value, all these things. Similarly here also we have to follow the OSPF header format. We have to maintain the version value, type value, but in the previous RAP we have to maintain the command value, but here we are not required for that. Instead of this one, we have to maintain the what kind of router ID we are using that one, what kind of area ID we are using that one. Apart from this one, what is my packet length value, what is the packet architecture length value, which is 15 to 31 bytes. So that is a maximum length value. We are using that one, and we have to follow checksum mechanism and authentication type values, because authorized person can able to handle this one, because information is transferred from inter-network to inter-network. So we have to go for this authentication aspect as well. And what is advantage? We have using this low traffic and fast coverage and large intermetrics, and based upon area based topology and route summaries and authentication. So when information is transferred from inter-network mechanism to inter-network mechanism, so this kind of structure scenario is there. So within the regions are there, low traffic is there, because limited kind of hubs are involved, and multiple hubs are involved to share the information from one hub to another hub. So at the same time, fast coverage is there, and this purely based upon this area based topology services. But what disadvantage? So here we have to maintain the memory. We have to maintain the lots of memory. We have maintain that one, and we run the multiple processor thing run at a time. So that is a very hectic for us, and this is configuration is very complex, not simple as RAP1. So I conclude the session. In this session, we are discussed about this what is RAP protocol, which is routing information protocol, and how it is suitable to my link state protocol and OSPF architecture one. So here, while discussing in this RAP protocol and OSPF protocol, one is the limited one, and there is a wider one. This, but one there go for this. These also limitations are there. And RAP we have limitations of this based upon hub structure. Here we have limitations of this processor one and a runtime consumption one. But to overcome these kind of issues, we are using in the another mechanism we calling as a path vector routing mechanism in the routing algorithm value. So in the upcoming session, in the next session, we are going discussing in depth of this what is a path routing algorithm value, how we are able to route the mechanism value, that we discuss in the upcoming session. Thank you.